Hello, my name is Madeline Seiler. I am associated with Ripon College and I'm presenting on the effects of unstable surface closed-kinetic chain exercises on the hamstring quadricep ratio and neuromuscular activation. Due to the differences between the anatomical structures of the two sexes, females have an increased risk of ACL injury, whereas males have an increased risk of hamstring strain injuries. Females have shown to have an increase within their quadricep activation levels compared to hamstrings during exercise. This results in a lower HQ ratio and an increase in the tensile force placed on the ACL that creates the increased risk of ACL injury. An example of this is while performing the closed kinetic chain exercises, side lunge or single leg squat, the HQ ratios in females have found to be lower than in males. By furthering our knowledge within the relationship between the hamstring and quadricep, we will be able to provide a greater understanding of the increased risk for injury during CKC movements and during movements on an unstable surface due to the increased need for control of knee stability to maintain balance. We will also be able to provide a higher quality of prevention and rehabilitation of ACL injuries. The purpose of our study was to examine the effects of performing CKC exercises on stable and unstable surfaces on the HQ ratio and motor unit recruitment in males and females. 10 males and 10 females volunteered for the study. Participants had to be between the ages of 18 and 30 years old, as well as recreationally active. Surface electromyography was recorded from the hamstring using the biceps femoris muscle and the quadricep using the vastus lateralis muscle on the participant's dominant leg. Following a 5 to 10 minute self-paced sub-maximal cycling warm-up, participants performed maximal voluntary isometric contractions on a seated leg flexion and extension machine, which was loaded with an immovable mass. Finally, participants performed the 3 CKC exercises listed here on both stable and unstable surfaces 3 times in a randomized order. Raw EMG recordings were normalized to MVICs and analyzed for root mean square. The HQ ratio was calculated using RMS as biceps femoris over vastus lateralis. All data was analyzed via SPSS using mixed designed repeated measures ANOVA. There was a main effect of condition of the HQ ratio and RMS of the vastus lateralis during both the front lunge and single leg squat, with a significantly lower HQ ratio as well as a greater RMS of the vastus lateralis during unstable versus stable. While there was no main effect of the biceps femoris during the front lunge, the RMS of the biceps femoris was significantly lower during unstable versus stable during the single leg squat. During the side lunge, there was a main effect of the HQ ratio with a significantly greater ratio during unstable versus stable. There was also a main effect of the RMS of the vastus lateralis and biceps femoris with the lower RMS of the vastus lateralis and greater RMS of the biceps femoris during unstable versus stable. Despite the previous literature, no significant differences were observed between males and females. We also found that performing CKCs on an unstable versus stable surface results in changes in HQ ratio and motor unit recruitment of the biceps femoris and vastus lateralis muscles. These findings will aid in the rehabilitation, prevention, and care of knee injuries, as well as assessing the muscular imbalances in which these injuries are caused. Limitations within our study include the participants' joint angles, form, and weight shifting during the 3 CKC exercises. Future research should include the HQ ratio utilizing the semimembranosus and vastus medialis muscles, larger sample sizes, different age groups, and a more sedentary population. Thank you.